Hi students, let us solve the following exercise about center of mass and moment of inertia. In this case, they say that the four masses are connected by a massless rigid rod, and then they ask you to find the coordinates of the center of mass, and they ask you to find the moment of inertia about an axis that passes through mass 8 and is perpendicular to the page. Right? So let us start with the first part. We know that to calculate the x coordinate of the center of mass, it would be 1 over the total mass times the sum from I equals 1 to n of the product of m sub I times x sub I, right? So we have to multiply each mass times the distance from that mass to the origin. We know that the origin of this system is at mass A. So here we have the origin of the rectangular coordinate system. So we have here x-axis and the y-axis, and the origin is where on mass A. So now when we write the equation for the different masses we have in this case, we have that the x of the center of mass would be mass A times x sub A, that means the distance from mass A to the origin, plus mass B times x sub B, plus mass C times x sub C, plus mass D times x sub D. All this divided by mass 1 plus mass A in this case really, plus mass B plus mass C plus mass D, right? So now we substitute and we get that the x of the center of mass would be mass A is 100 grams. So we have 100 grams times the distance from mass A to itself is going to be 0 centimeter, plus mass B. Mass B is this mass over here, which is 200 grams, and the distance, along the x-axis from mass B to the origin is going to be 0 because the mass B is on the y-axis. So the x-coordinate of the mass B will be 0. So it's 0 centimeter, plus mass C, which is 300 grams, times the distance along the x-axis, which is going to be 10 centimeters, because the coordinates of this mass is just 10,8, plus mass D, right, which is in this case 200 grams, and the distance, from mass D to the origin would be 10 centimeters. Now we're going to divide all these by the total mass, which is 100 grams plus 200 grams plus 300 grams plus 200 grams. If we calculate that, of course, this term here will be 0. This term will be also 0. So we're going to calculate, and it would be, the numerator would be 5,000 grams centimeter, and the denominator would be 800 grams. So we're going to get 6.25 centimeters, right? Which is approximately 6.3 centimeters, and in meters it would be 0.063 meters, right? So we have the position of the center of mass, right? In this case, the x coordinate of the center of mass, in this case in centimeters and in meters. Now let us find the y of the center of mass. So we know that the y coordinate of the center of mass would be 1 over the total mass times the sum from I equals 1 to n of m sub I times y sub I, right? So now we're gonna just substitute the values of the four masses here. So we have that the y of the center of mass would be, in this case, well, we have mass A times y sub A plus mass B times y sub B plus mass C times y sub C plus mass D times y sub D, right? All these divided by mass A plus mass B plus mass C plus mass D. So the y of the center of mass would be, then now we have 100 grams, that is mass A. Now the mass A is in the origin, so it's 0 centimeter in the horizontal from the position of the origin, so it's just times 0. Now mass B, right, in this case, which is 200 grams, and mass B is 8 centimeters above the origin, so we have to include here 8 centimeter multiplied times 8 plus the mass C, which is 300 grams, right, in this case times the y coordinate of this mass C, which is also 8 centimeters, plus then mass D, which is 200 grams, times, in this case the mass D is a mass on the x-axis, so xy coordinate would be 0 centimeter. So we know this product would be 0 and this product would be also 0. We divide then all this by 100 grams plus 200 grams plus 300 grams plus 200 grams. So when we find the y of the center of mass here, it would be, the numerator would be in this case 4,000 grams centimeters, and the denominator would be 800 grams. So when you divide that, you would get 5.0 centimeters, right? And in meters, this would be 0.050 meters. So we found the x and y coordinate of the center of mass. So this second part of the problem now is to find the moment of inertia, right, about the an axis that is passing through mass A, and there is perpendicular to the page. In this case, the first we need to determine here is the length of the diagonal that goes from mass A to mass C. So we need to find this length, right? Of course, we can use the relation between the side of a right triangle, because here we have a right triangle with right angle at mass D, right? So we know that this side of the triangle, which is 8 centimeters, now I will work in meters because I want to get my moment of inertia with respect to point A, or to mass A, now in kilograms meter square. So this is 0.08 meters, and this other side of the triangle would be in this case 0.10 meters. So if we find now the diagonal that we have over here, this diagonal is equal to the square root of the sum of the squares of these two sides. So it would be, you do the calculation, 0.13 meters. 0.13 meters, right? So now we know the distance of V from 8, the distance of mass D with respect to 8, and the distance of the mass C with respect to mass A. And why we need to do that? Because in part 2, when they ask you to find the moment of inertia about an axis that is passing through mass A and that is perpendicular to the page, to find that moment of inertia with respect to A, you say that is equal to the sum from I equals 1 to n of your m sub I times r sub I square. So you need to know each mass and the distance, from each mass to, in this case, mass A, right? That is the reference, right? Because the axis is passing through that mass. So we can say that this moment of inertia with respect to point A here is going to be equal to, well, we have first mass A times r sub A square plus mass B times r sub B square plus mass C times r sub C square plus mass D times r sub D square, right? So the moment of inertia here with respect to A would be mass A is 100 grams, okay? So I will just convert that to kilograms. It's gonna be 0.1 kilogram, right? Times, I will just work in meters. So the axis is passing through A, so it's 0 meters from the axis, right? So it's times 0. Plus now mass B is 200 grams, and then of course this is a square here. The distance from mass B to mass A is gonna be 0.08 meters, right? So we say 0.08 meters square. Plus now mass C is 300, and I will just put it here below, is 300 grams times the distance from mass C to mass A is 0.13 meters. So we can say here 0.13 meters square. Plus, then finally we have mass D, which is 200 grams. And the distance from mass D to mass A is 0.1 meter. So we say times 0.1 meter square. So we can do the calculation now, and we're going to get, when you do all the calculations, 8.35 times 10 to the negative 3 kilograms meter square. And with that, we found the moment of inertia with respect to an axis that is passing through point A, and there is perpendicular, to the page. I hope this exercise, was interesting for you. Please support my channel, subscribing, to this channel, and you will get notifications of every new video. Thank you so much for your attention.